we will discuss the question whether mathematics is related to nature or how mathematics we can find in nature. This is, in a word, the answer is yes, but it is difficult to spot. We have to do some work to find how mathematics is there in nature. If I say that in a breeding of rabbits problem there is a simple sequence, then you may not believe. Or if I say the same sequence, using the same sequence, we can create a spiral that we can find in the seashell. Using such problems, we will see how mathematics is we can find in nature. In the behavior, we see that the shells, they are in hexagonal shape. Why only hexagons, not squares or triangles? Because the simple answer is because hexagons are most closely fit together, leaving no gaps in between. That is, they are the ideal shape that maximizes the space available. If we take the problem of multiplication of rabbits, it is related to a simple sequence I will show. The sequence is the P.V.P sequence given by famous Italian mathematician P.V.P. The sequence is like this: 1, 1, 2, 3, 5, 8, etc. etc. What is the sequence? Sequence is just an arrangement of numbers in some order. If our first terms are, we see they are 1 and 1, their addition is 2. Then next the numbers are 1 and 2, their addition is 3. Then the next numbers are 2 and 3, their addition is 5. In this way, the sequence we are getting it is a P.V.P sequence. Now, if I consider the problem of breeding of rabbits, in an ideal situation, say there is a pair of rabbits, one male and one female. They can mate after 1 month and again give birth to another pair of rabbits, which is again, we say that one is male, always male, and one is always female. Okay, and no rabbit dies. In this situation, we see that in the first month there is only one pair of rabbits. This initial pair of rabbit becomes adult in the next month. Then in the next month also there is only one pair of rabbits. In the next month it gives birth to another pair of rabbits. Now there are 2 pairs of rabbits. Now this pair becomes adult in the next month and the original pair it is again giving birth to another pair of rabbits. Now there are 3 pair of rabbits in the 4th month. In the 5th month, in the similar way, we will see that there are 5 rabbits. Then in the next month there will be 8 rabbits. We see that this is the P.V.P sequence. Okay, that we discussed earlier. Same P.V.P sequence we can find in the growing points of plants. Okay. In the first month there is only one stem. In the next month there is also only one stem. In the next month there are 2 stems. Then in the next month there are 3 stems. We see that again it is a P.V.P sequence. And this P.V.P sequence we can find in the plant Achila Pravaranagar. Okay. And using this P.V.P sequence we will create a spiral. Suppose we have 2 squares of 1 unit square each, and on that we put another square that is of 2 square unit. Then by its side we put 3 square unit square. Then below it we put 5 square unit square. Then 8 square unit square, like that. And in its diagonal we create a spiral. This is called the P.V.P spiral. It is, we can find it in the seashell. In our ear also, the same spiral is there. And in the universe, we We see that the stem spiral is there. In Marathi we say पिंडी आणि ब्रह्मांडी एकच स्पायरल आपल्याला मिळतो. In cauliflower also we can find same spiral. In pine cone we can find the same spiral. These P.V.P spirals or P.V.P numbers we find in flowers also. We see that in this flower there are some spirals which are curving left and there are some spirals which are curving right. And these spirals form the consecutive P.V.P numbers. In the case of this flower, that is, here we see that there are 34 spirals curving left and there are 55 spirals curving right. They are the consecutive numbers in the P.V.P sequence. And here also we will discuss the same thing, how P.V.P sequence occurs in flowers. We see that in nature we can find flowers with 3 petals, 5 petals, 8 petals, 13 petals, 21 petals, 34 petals. You see that these are all P.V.P numbers. But it is very difficult to find out flowers with 4 petals because 4 is not a P.V.P number. We see that nature understands P.V.P. This fractal is another interesting example how we can find mathematics in nature. What is a fractal? Fractal is a shape which repeats itself in every scale. We see that if I construct a simple fractal, suppose I take a line, in its middle, I rub the middle line and draw another 2 diagonal lines. These 2 diagonal lines, again I draw them, rub it in middle and draw again another 2 lines, diagonal lines. Same way I do for others. Here also, we see that this pattern is repeated infinitely many times in every scale. We will get a fractal that we call as cone fractal, okay, that we have observed in nature. Here also we have in the last scale taken the same fractal. It is also called as the post snowflake. And these fractals we also observe them in nature. That is, in case of plants, we will see some fractal trees, some fractal ferns. Then next, some fractal spirals. And now I have a question. If we are given with these rectangular frames, which frame you will choose for your photo? Of course, the answer is this frame, that is C. It is the most aesthetic frame that we like. We tend to like this frame. Why? Because something that we find attractive, it has some kind of symmetry. And in mathematics, we say that it has also some kind of a ratio. That ratio, we call it as divine ratio or golden ratio. Something that we find attractive. There are some certain shapes, symmetries as well as this ratio. There is mathematics of beauty also, and beauty of mathematics always will. Okay. Next. In Leonardo da Vinci's picture, we find that this golden ratio is used. Foot to navel and navel to head. This ratio must be in some kind of proportion. That proportion is divine proportion or golden ratio. Also our arms, our nose, or this adjustment of our eyes, this should be in some kind of ratio. That ratio is also golden ratio. Something that we find attractive, that is due to symmetry and this ratio. This ratio it is called as the golden ratio. It is this part, it is 1.618033. Where it comes from? If we take the P.V.P sequence 1, 1, 2, 3, 5, 8 and the consecutive terms we divide. Okay? Then 1 divided by 1 it is 1, 1 divided by 2 it is half, 2 divided by 3. Okay? Like that 0.66. Then it will converge to this number, that is pi, that is this golden ratio pi. Here it converges to 1.618 etc. This number is the golden ratio. Same golden ratio we can find in the famous structures, that is the Greek statues, the Parthenon, Leonardo da Vinci's pictures, all these architectural monuments, there we can find the golden ratio. Here we can see that same spiral that earlier we constructed, that is present in this structure. Okay? In this pyramid also, some kind of relationship of this golden ratio we can find out. Mathematics and architecture, they are also related because they both involve symmetry as well as these ratios. These structures, they are all in some way related to these ratios and hence to mathematics. Okay. In this also we can see the symmetries. In natural patterns, that is in plants, minerals, animals, water, some kind of natural patterns we observe, that different spirals, they are in way mathematical structures. Here also we can see some spirals. And we see that some insect perform some kind of complicated tasks which are beyond human beings. These tasks are unknowingly performing higher mathematics. We see that all these simple things indicate that nature is using some kind of mathematics. If we people say that mathematics is not simple, it is just because we don't understand how complicated our life is. Okay, using these simple examples, we demonstrated how mathematics is related to nature. You yourself can explore some more examples. Thank you.